Hello everyone and welcome to ILAN Technologies presentation on Draytech Wireless Mesh Solutions. This is part 2 of our two-part webinar series on the topic. In this webinar we'll continue on from part 1 where we introduced the wireless mesh solutions available in the latest Draytech wireless routers and access points, and we'll go through management and troubleshooting of wireless mesh installations. My name's Darren and I'm the Queensland sales rep at Draytech Australia and New Zealand. I'll start with a brief recap of our previous webinar, including the maintenance options available. Then I'll go through the mesh maintenance tasks listed here, as well as mesh monitoring. If you have any questions during the video, please comment in the chat box on the right side of the screen and stick around at the end for a 5-minute Q&A session. If you're watching this after the premiere, please comment below or send an email to sales@draytech.com.au. Okay, just in case you missed our previous webinar, I'll briefly go over the main points that were covered. We discussed what a wireless mesh network is and that it can be used to quickly extend the wireless network to cover areas where no Ethernet cabling is available, and how it creates a seamless Wi-Fi roaming environment. This means users can roam around the premises, switching APs, and always be connected to the Wi-Fi as if it was one big access point. There are a number of Draytech access points shown here that support wireless meshing. They all can be used as mesh root or mesh node devices, with the exception of the VIGA AP802, which can only be used as a mesh node device. Router models supporting the wireless mesh feature are shown here. These routers only support mesh root mode. Broadband routers are the VIGA 2926 and 27AC, VAC and LAC models. DSL routers include the VIGA 2862, 65 and 66 AC, VAC and LAC models. The AX or Wi-Fi 6 routers currently do not support Wi-Fi meshing. We then looked at the steps to deploy a wireless mesh network by using the Quick Start wizard to enable the mesh root and then discover the mesh nodes. There's 3 steps to creating a mesh group. The first step is to configure the mesh root. Next, we place the mesh nodes close to the mesh root, then scan and add members into the mesh group. The mesh root then pushes the configuration to the mesh nodes. Once this is done, move the mesh nodes to the designated positions. Finally, power on the mesh nodes hop by hop, making sure their statuses are online. It is recommended to first power up the mesh nodes closest to the mesh root, so these uplinks can be selected first. Then power up the mesh nodes that are further away. This will avoid the mesh root from selecting the weaker link as the primary uplink to other mesh nodes. When completed, the mesh group is ready to serve the clients. Once the wireless mesh is up and running, we can look at wireless mesh management maintenance tasks. When building a wireless mesh group, you might encounter some issues where some nodes may not connect. The first place to look is in the link status section in the mesh status menu page. In the mesh root device, it should show as connected for link status. The link status message will be different depending on the state of the devices in the mesh group. This table shows the different messages you'll see when the wireless mesh is being set up. When the mesh root is in the process of adding a mesh node, you'll see the message registering in the root device and connecting in the node device. There are other messages for link status depending on the state of the devices. You can pause the video here if you need more time to look at the table. When all mesh links are working normally, you should see the connected status message on both the root and node devices. In the mesh status page, you'll also notice a green icon next to the mesh node devices, indicating that they are connected and online. There's also an option to run a speed test to each mesh node. This can be used to verify performance between mesh root and mesh node and will help you to place the access points in the best locations. The locations where mesh nodes are deployed will affect the uplink signal strength and thus impact the overall performance. To run the speed test to a mesh node, click on the Start button next to the wireless node. After clicking on Start, you'll see a page similar to this showing between which devices the speed test will be done. Click on the green button marked as Test to run it. It takes about 30 seconds for the results to appear. When running the speed test, the result is from the node to the root through intermediate nodes. For node A shown in this diagram, the speed test result is the data rate for the path shown in red. You can also verify the performance between a Wi-Fi client and the internet. In the example shown here, we have a mobile device shown as B connected to the mesh Wi-Fi, and we want to run a speed test of the internet as shown by the red path in the diagram. This test can be done through the Draytec Wireless app. Another speed test can be done from the Diagnostic Speed Test menu in the access point. This will verify the performance between the Wi-Fi client shown as C in the diagram and the access point shown as D. The speed test result will be displayed as shown here. Both the download and upload speed test results will be shown. To illustrate how the speed between nodes affects the overall speed to the internet, I have two examples here. In the first example, device A can only have a maximum speed to the internet of 50 megabits per second, since the overall speed can only be as fast as the slowest link. Similarly, in the second example, device B is connected to a mesh node several hops away, and each link has a different speed. However, since the slowest link is 30 megabits per second, then the maximum speed achievable by device B will also be 30 megabits per second. We'll now look at communication between the mesh root and mesh node. Most commonly, this is done over a Wi-Fi band. The selection of the wireless uplink downlink band can be either 2.4 GHz or 5 GHz. In the mesh setup menu, we have three options: auto, 2.4 GHz or 5 GHz. When auto is selected, mesh root and nodes can connect via any enabled wireless band. It'll evaluate the hop count, RSSI, and estimated link rate to select which band to use for the first hop in the mesh. Usually 5 GHz is auto-selected since it has a higher evaluation score due to its higher link rate than 2.4 GHz. Subsequent hops in the mesh will follow the band selection used for the first hop. So we can see in this diagram, hop 2 and 3 mesh nodes will use the same download link used for hop 1. In addition, the mesh root can simultaneously use a different downlink band for each hop 1 mesh node. In the mesh shown here, we have one branch using the 2.4 GHz band and the other is using the 5 GHz band for communication. One point to note is that the mesh root and wireless mesh nodes should use the same wireless channel for the uplink downlink band. This is normally automatically done for you when setting up the mesh network. If you change the wireless channel on the uplink downlink band, it'll cause mesh disconnection. This does not apply when wired uplink connections to mesh nodes is used. Wireless mesh nodes automatically select the next hop in the mesh to connect to the mesh root. However, the next hop may not always be the best node to connect to achieve stability. This can occur when a mesh node is still burning up during the path selection process, or an access point may be offline. This can result in the next hop selected going to an access point with a weaker signal. The preferred uplink feature is available to allow you to select another mesh node as the preferred uplink. This prevents the mesh node from setting up an uplink to a device with a lower signal strength. More information on this is available in Knowledge Base 7483 if you'd like to find out more. As always, I'll include a link to that in the description below. Here we have the preferred uplink menu option in the general setup menu. The Vigor AP918 RPD at number 2 has been selected as the preferred uplink here. The preferred uplink option can be used to deploy mesh network topology according to your custom network design if you wish to have control on how the mesh nodes are interconnected. When using the preferred uplink option, there are some things to be aware of. The first is when the preferred uplink AP goes offline. The mesh node retries the connection for a preset time as set in the preferred uplink timeout setting. This is configurable for between 1 and 10 minutes. If the preferred uplink is still offline after the timeout period, then the mesh node will try to find another uplink. Next item is if the preferred uplink AP comes back online after the timeout period has expired. In this case, the mesh node will not change to the preferred uplink connection until the next disconnection and reconnection event. This is to avoid interruption to the mesh network. Next we have if the preferred uplink is removed from the mesh group or the mesh group is reset. When this happens, the preferred uplink setting will be cleared and the network administrator will need to re-enter this setting. Finally, for a working mesh group, changing the preferred uplink AP will not disconnect the existing uplink immediately. New preferred uplinks will take effect after the next disconnection and reconnection event. Okay, let's now look at some wireless mesh maintenance tasks. The first task we'll look at is deleting mesh nodes. You might need to do this when removing some nodes from the mesh so that they can be used on another network. To do this, select the required devices to delete from the list in the General Setup menu and click Delete. The information cleared is the mesh group information, admin password, SSID and security settings. If the mesh node is online, it will be reset. Another task that can be done is to reset the mesh group from the mesh root device. This is done by clicking on the Reset button in the General Setup page in the mesh root. It can also happen when the operation mode is changed in the mesh root. Once the mesh group is reset, all the mesh nodes will be notified to reset the mesh settings to the defaults, which includes the mesh group information, admin password, SSID, and security. Much the same as deleting mesh nodes, if the mesh node is online, it will be reset. Offline mesh nodes will not receive the notification to reset, so they'll have to be manually reset. If you need to make configuration changes to the mesh network, the most efficient way is to change the settings in the mesh root device. This can be done in the Mesh Basic Configuration Sync menu. Once the required changes are made, click on the Sync button to push the settings to all mesh nodes. The settings that can be changed include management settings in member access points, 2.4 and 5 GHz wireless LAN settings, and policies for Wi-Fi clients. Uplink optimization is another function available in Draytech wireless mesh networks. This is used when a mesh member reboots or joins or leaves the group, which will cause the uplink path to change. Enabling the auto reselect function in the mesh root is required here. The auto reselect process will start when all of the following requirements are matched. The first is that auto reselect is enabled. Second, auto config sync of all mesh nodes are done. Third, at least one wireless mesh node should be online. Fourth, the mesh member changed, for example, they either joined or left the mesh group, and the last change happened at least 1 minute ago. And lastly, when the auto reselect process has finished for more than 3 minutes. Uplink optimization can also be done manually by clicking on the Reselect button in the Mesh Status menu page in the mesh root. For a single mesh node, you can force an uplink optimization by clicking on the Disconnect button for that node. It forces the selected mesh node to disconnect from the current uplink and reconnect using a better uplink. This table has a summary of everything we just discussed regarding auto uplink optimization. You can pause the video here or maybe take a screenshot if you need more time to read the details. It is possible to change the wireless channel used by the wireless mesh network, perhaps to avoid interference from new devices located in the area. That will cause the mesh network to be disconnected for a short period while the mesh is built up again. The process involves first changing the wireless LAN channel in the mesh root. The mesh nodes will then be disconnected and they will scan and find the new channel used by the mesh root. The mesh nodes will then automatically change to the same channel as the mesh root. Once the mesh uplinks are re-established, the mesh network will carry on as normal on the new channel. The mesh root also has an option where you can create a backup of the settings used. This might come in handy if you need to replace the mesh root with another device one day and will save you the trouble of having to reconfigure the new mesh root from scratch. To create the backup, click on the Backup button in the Mesh Config menu and save the file to your PC. Information that is saved in the backup includes the mesh group details like the group name, role, MAC address, model, and the device name of each mesh member. Log level, wireless uplink downlink band, admin name and password, wireless LAN 2.4 and 5 GHz settings including SSID 1 and the PSK, auto reselect and the preferred uplink and timeout settings. To restore the file to a new mesh root, select the file from your PC and click on the Restore button. When replacing the mesh root, there are a few steps to follow. First, ensure there is enough quota for a new mesh node, since a maximum of 8 devices can be used in a wireless mesh network. Then reconnect the new AP to the mesh root as a wired mesh node. Next, make a backup of the original mesh root. Now change the operation mode of the new AP to be mesh root. Power off the original mesh root to prevent mesh members connecting to it, and finally restore the mesh backup file to the new mesh root. Now the mesh nodes will be transferred to the new mesh root. The procedure to follow when you have a hardware failure of the mesh root is different. If you have a mesh backup file, you just need to change the operation mode of one of the mesh nodes to be mesh root. Then restore the backup file and the mesh members will now be transferred to the new root. However, if you don't have a mesh backup, you'll need to reset all the mesh members to factory defaults and reconfigure from scratch. This table has a comparison of using the mesh backup option compared to configuration backup. One point to keep in mind when adding a new device to the mesh group is that if the destination AP is not a mesh member, that is, its MAC address is not in the backup list, then some restore actions will fail. The final topic we'll look at today is wireless mesh monitoring. There's two ways to monitor Wi-Fi client connections in the mesh. The first is to go to the mesh station list menu in the root access point. Here we can see a list of connected clients. It displays the MAC addresses of each station along with additional information which includes host name, vendor, SSID, channel use, signal strength, and transmitted and received data rates. The other way to monitor Wi-Fi client connections is to use the Dratec Wireless app. It's available for both iOS and Android devices and can be downloaded from Apple or Google. I'll include that link in the description below if you have any trouble finding it. The app shows similar information to that displayed in the station list in the root AP, but in a more graphical layout as shown in these images here. In the root access point, you can also look at the mesh syslogs by going to the mesh syslog menu page. Here, mesh-related syslogs are filtered out and displayed, which helps to spot any problems when creating or managing the mesh network. If you use the syslog utility, after capturing the syslogs, you'll find a mesh tab you can select to filter out any mesh-related messages from the logs. Okay, that's all for now. So to summarise, today we started with a recap of our previous webinar, then we looked at wireless mesh management, followed by mesh maintenance tasks, and we concluded by looking at mesh monitoring. If you have any questions, please stay tuned. We'll be available in the live chat on the right of your screen for the next 5 minutes. For more information about Dratec products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or give us a call on 02 9838 8899. Please like and subscribe below, and if you'd like a notification anytime we put up a new video, please give the bell a click too. Thanks and bye for now.